In this video, we're going to take a look at average and instantaneous rate of change. So really quick, I want to tell you what each of those mean. So for average rate of change, think about driving from Los Angeles to New York City. You are not going to be going the exact same speed the entire time you're driving, but you can find your average speed by going your distance equals rate times time and then just dividing distance by time to get your rate. And that is the average rate of change. Now, instantaneous rate of change is if you're looking at your speedometer and you have the exact speed you're going at an exact instant. That is instantaneous rate of change. All right, so first of all, let's talk about how to find the average rate of change. We have seen the average rate of change before. In fact, it is within our slope formula. So our slope here normally is your slope is equal to y2 minus y1 over x2 minus x1. Now I hope that looks familiar to you. But if we have a graph on a slope, it was usually if you just had a straight line and you found the slope of the line. Here, if we have a graph and we have 2 points on our graph, let's say that this was our Los Angeles and this was our New York. The average rate of change is the slope of the line between our start value and our finish value. So we have to find our x and y for my first value, and we have to find our x and y for my second value. So that means the formula for average rate of change will look a little different, but the concept is the exact same concept as slope. So our average rate of change formula is f of b minus f of a divided by b minus a. And a is the x value of our first point, and b is the x value of our second point. Let's look at an example that uses the average rate of change. So in this problem we have, find the average rate of change of the function at the given interval, and my function is f of x equals x squared minus x plus 10, and the interval is from -1 to 5. So we're going to first find this. We're going to find f of 5 and subtract f of -1. And then we are going to divide that by 5 minus -1. So first then, we should find f of 5. If I plug 5 in, I get 25. Minus 5 is 20, plus 10 is 30. And if I plug -1 in, I get -1 squared is 1, minus -1 is 2, plus 10 is 12, so it's 30 minus 12, which is 18. And then 5 minus -1 is 6. And 18 divided by 6 will be 3. So the average rate of change of that function on the interval is equal to 3. All right, so now let's take a look at what instantaneous rate of change is. If I have a graph here, and if I wanted to find the average rate of change, once again, I would have my A value and my B value, and I would just find the slope between the two. Now, instantaneous rate of change, instead of going between two values, you have one specific value. All right, so for instantaneous rate of change, what we will do is, instead of having an A and a B value, we will have an A value, and then we will have another value that is our B value, but instead of calling it B, we're going to say it is A plus H. Meaning that it is H units away from the initial A value. Okay, this A, I didn't plan that very well, is the Y value for that A is f of A, and the Y value for A plus H is f of A plus H. Okay, now we want to find when the distance between the two values is getting closer and closer together. So we want that distance of h to get closer and closer to a, which means we want h, the distance of h, to approach 0. So instantaneous rate of change is the average rate of change as the distance between my A point and my B point approaches 0. The distance between my A point and my B point is h, so as the distance of h approaches 0. This means that the formula for the instantaneous rate of change will be the limit as h approaches 0, because h is the distance between my A and my B, of f of a plus h minus f of a all divided by h. So let's take a look at a couple examples, and as we do the examples, I'll show you the steps to solve one of these problems. The example would be, find the instantaneous rate of change of a function at a specific x value. Now, in order to find an average rate of change, you must have two x values, or an interval. To find instantaneous rate of change, you only need one x value. So, let's look at the steps on how we would get started on this problem. Alright, so step 1 is to plug a plus h and a into the function, which means I want to find f of a plus h, and I want to find f of a. Now, f of a plus h is fairly simple. Don't get too caught up on it. You just take a plus h and plug it in wherever there's an x. Now, you can FOIL it all the way out here. Might be a little bit easier. We would end up with a squared plus 2ah plus h squared plus 1. And then if we plug, so this is a plus h, sorry. Then we're going to just plug a into the function and we end up with a squared plus 1. So we have f of a plus h and f of a. Step 2 is to put what you found for f of a plus h and f of a into the equation for instantaneous rate of change. So we have here the limit as h approaches 0 of f of a plus h, which is this right here, so all of that, a squared plus 2ah plus h squared plus 1, so there's f of a plus h. And then the next part of the formula is minus f of a, which is just a squared plus 1. Now it's important that we subtract all of f of a. Okay, so make sure you have a parenthesis around f of a if there's more than one piece to it. And then all of that divided by h. Alright, so step 3 is, if possible, simplify so that h is either out of the denominator completely or 0 can be plugged into h without any restrictions. So let's take a look at what that means. So I want to go through and cancel anything out first if I can. So see how I have a squared minus a squared? Those will cancel out. And I have plus 1 minus 1, which would also cancel out. So what we are left with is the limit as h approaches 0 of 2ah plus h squared. The whole backside canceled out, so we have divided by h. Now what you can do is we can factor an h out. So I'm just going to rewrite a sub part here. I have 2h plus h divided by h. And since h was factored out, do you notice what can happen here? The h's can cancel. So we have then just the limit as h approaches 0 of 2a plus h. All right. Step 4, we're close to the end, but step 4 is to plug this right here. Now that we have this, we're going to plug 0 in for h. So we have the limit, if we have the limit as h approaches 0 of 2a plus h, we're going to plug that 0 right there in for h. And we're left with 2a. At this point, we no longer have to write the limit because we've solved our limit. Okay, so this means that anywhere on that function, our original function, at any point a, we could plug the a value in, the x value in, and get what our instantaneous rate of change is. So our last step is to plug the given x value up at the original problem into a, here, into this a, to find the instantaneous rate of change. So our original problem said that x was equal to 8. So that means we're going to plug 8 into our a. A represents the x value at a given moment. So our given moment is when x is 8. So my instantaneous rate of change is equal to 2 times 8, which is 16. Now we don't really have a set of units here. So our final answer is simply 16.